Hello and welcome to the lab video. As you see on the screen, I have the lab open. And if you take a look, there's these very, very large paragraphs that go over water potential. So if you're still a little bit confused about water potential, the first page and then the second page, we view a little bit about water potential and sort of how you do the calculations and things like that. And it continues, and so if you're confused about water potential, it's actually a pretty good read. So in this lab, our goal, let me go to the Smartboard notebook. The goal of the lab, why did you stop? There we go. Goal of the lab, you're not writing. I got it right. So the goal of the lab is to determine the water potential of some potatoes that I'm going to go to the store and buy in a few minutes. To do that, I just slaved over making different concentration sucrose solutions. So we're going to have distilled water, which has a concentration of 0. Then I make 0.2M sucrose solution, 4M sucrose solution, 0.6M sucrose solution, 0.M sucrose solution, and 1M sucrose solution. Sucrose is the chemical name for sugar. So I just made, about 2 minutes ago, all these different concentrations of sugar. Then you're going to have these cups. There's my cup, my triangle cup. And you're going to pour, okay, the solution that you're assigned, and you'll see in a second, in the cup. So, looking at the lab, you're going to be pouring 100 milliliters of the solution you're assigned. You're going to be assigned 3 or 4 solutions into the cup. And then I'm going to pre-cut for you so it occurs faster, because we don't have that much time, these tiny, tiny little cores of potatoes. They look like, to be honest, can't believe I'm saying this, they look like potato cigarettes. Okay? And you're going to have 4 of them. Obviously, they'll be smaller because they'll fit into the cup, but you're going to have 4 of them. And you're going to mask these potatoes. So I'll give them to you. They're going to be pre-cut because they take a while to cut, and we don't have a lot of time on Thursday. And you're going to weigh the 4 of them on the scale and record it. If you take a look at the procedure, there is a place to record the initial mass. So here's the place to record the initial mass of the potato. Once you find the mass, you're going to take your potato cores and stick them in the solution that you've been assigned. At that point, they are going to stay overnight. And then on Friday, when we come into class, we're going to see how much the mass has changed. Okay? Now, using the data that we get, and I'm going to explain this more on Thursday because it's a little complicated and hard to do through a video, we're going to be able to calculate the water potential of the potato using this data. What is the water potential of potato tissue is what our goal in calculating. Now, what I would like you to do now where you're writing this, okay, is hypothesize each of these solutions, okay, what is going to happen to the mass of the potato. So what do you think after we take it out of the solution? Just hypothesize. It doesn't matter if you're right or wrong, Angelica. All right? Just hypothesize what you think is going to happen to the potatoes when you put them in the solution. Are they going to get heavier? Are they going to get lighter? And I want you to hypothesize that for each solution. So we're back on the lab, and I just want to show you, on Friday we're going to calculate the final mass here, and then we have some calculations that we need to do. We'll discuss those on Friday. And then we're actually going to have a class data table that puts everyone's class data together. Here is the procedure. So on Friday, I'm doing number 1 for you, which is to cut the cores, which I'll be doing for you on Friday. And you're going to pour the 100 milliliters of solution into the beaker. I'm going to be doing the cutting for you. And then you're going to mass your 4 cylinders. And then you're going to put them in these, it's actually not a beaker, I have these plastic cups. And then they're going to, number 6, they're going to let sit overnight. It's important though, each of you you're gonna have 4 solutions, so it's important you remember which potatoes you put in which cup, because their masses are gonna be different, so that's important. You need to remember, you're gonna mass a potato and put it in either the 0.4 m solution, the 0.6 m solution, so you need to remember which potatoes went in which cup when you mass them, because you have to have the mass correct. So these are the groups that you're going to be in on Thursday. When you come in on Thursday, we're going right into the lab. Dylan, you're going to sit where Dylan sits. Tommy's group is going to sit where Tommy sits. Brian's group is going to sit where Brian. And then Dan's group is actually going to sit where Morella is, because Dan and I think Dylan are too close to each other. So Dan's group is going to sit with where Morella's group is. And you look at the top here, these are your assigned solutions. So Dylan's group is doing 4 solutions. 0 m, which is distilled water, 0.2 m, 0.4 m, and 0.6 m. Tommy and Matt's group, because there's only 2 of them, they're doing 3 solutions. And then Brian's group is doing these 4 solutions. And then Dan's group is doing these 4 solutions. Notice that they're out of order. Like, these go from lowest to greatest, but these don't. And that's because there's only one container with each solution. So you want to start with the 1 m so that no one else is trying to get the 1 m at the same time. This should take, the weighing and the pouring should take all of 15 minutes. Okay, like you need to be ready to go when you come in. Literally, the weighing, should take 15 minutes. Like pouring and weighing, like 2 minutes each. There's 6 of them. Like there's 4 of them, like 8 minutes. But I know that you guys get confused, so it might take a little bit more time. But this should be quick, and all they're going to do is sit overnight. And we're going to get the data on Friday when we finally have a full class period. Oh. After the lab, which should take, like I said, 15 minutes, we are going to be doing the do after lab, which is right here. And then we're going to start continuing going over some of the issues with water potential, because again, we went through water potential really quickly today. So for homework, I should see stuff written on your lab that I wrote on the smartboard, and I should see your hypotheses. And then the other homework was the questions, I think it was 1, 4, and 7 on the water potential homework packet. Enjoy the internship day, and I will see you on Thursday.